Alright, gang. So this takes us to 2-4, linear equations continued. Same handout as we used for 2-3, because obviously on this handout in 2019, 2-3, comma 4. So 2-4, and we're going to kind of pick up where we left off, and starting with the whole x-intercept and y-intercept thing. Now obviously you should already know that in the last section we were looking at some stuff with y-intercepts because we were working with y equals mx plus b in order to graph an equation, to graph the line representing, the solutions of a certain equation. And so we were, and the b in mx plus b means the y-intercept. But overall here, the x-intercept is the point at which the line crosses the x-axis, and the y-intercept is the point at which the line crosses the y-axis. And here's a question for you. What do all the x-intercepts, have in common? And not specifically, that they're all on the x-axis. Let's be a little more creative than that. What does that mean, that they're all on the x-axis? So again, what do all x-intercepts have in common? What do all x-intercepts have in common? What do all the coordinates of x-intercepts have in common? That the y-coordinate is always 0. Again, like all the x-intercepts have a y-coordinate of 0. Likewise, what do all the y-intercepts have in common? That the x-coordinate is always 0. So as far as our homework is concerned, and any problem related to this, I guess you would see like on any test in the future or whatever, you would plug 0 into, you would plug 0 into y, and that would flush out the x-intercept. So you would plug 0 in for y and then solve for x, and that would basically be your x-intercept. Likewise, you could plug 0 into x, or in for x, plug 0 in for x, and that's going to flush out what the y-intercept is. In other words, you would plug 0 in for x and then solve for y. Like, right up here. I don't have to turn the page. So look right here. If I gave you something like this, and I asked you, what is the x-intercept, you would plug 0 in for y, and now you'd be able to solve straight up for x. Likewise, if I wanted the y-intercept, now listen to this. If I wanted the y-intercept, I suppose what you might think to do first is turn this form into y equals mx plus b form, because how the b in y equals mx plus b is actually your y-intercept. But another option you have is to plug in 0 for the x. 3 times 0 plus y equals 18, and just solve straight up for y, and that would be your y-intercept. So maybe if nothing else, to find your x-intercept, remember this whole set of options. I can even take this even further. Like, I can continue this conversation a little bit more by saying, like, well, why not, if you wanted to find the x-intercept, why not just graph this line, like get some graph paper, get some grid paper, or go on a graphing calculator, go on Desmos.com or whatever, and look at the graph of this line and just kind of eyeball on the graph where the line is intersecting the x-axis. Just kind of find the x-intercept on the graph, right? I'm not saying that would never work. That would work beautifully plenty of times, That would work great. Probably a large percentage of example problems you'd have to do. Looking at the graph, drawing the graph would work great. Just kind of, let's see where this line crosses the x-axis, let's set this equal to y. Y equals negative 3x plus 18. Obviously, the b value, the y-intercept, is going to be 18. Let's just draw the line and see. Here's the thing, though. It's very possible that your x-intercept is not going to be a nice answer. Let alone how your x-intercept might be off the page, out of bounds, like really, really, really far away from the origin 0, 0. Like, what if your x-intercept, what if your x-intercept was like negative 107, right? Negative 107. Like, what if your line wasn't going to cross the x-axis until negative 107? Now, I suppose a graphing calculator or a Desmos.com online graphing calculator, that probably wouldn't be a problem, but it could be a problem otherwise. And it could very well be a problem if your x-intercept is like really ugly, like 3.782593, you know what I mean? Like the nastiest decimal, right? Which, heck, as I even say this, and I elaborate more and more here, something like Desmos.com might actually be able to tell you that, to a certain point at least, to a certain decimal. Like, I actually imagine if your x-intercept was exactly 2.387 or something, 2.7835, whatever. And let me actually just pick something here. So 2.375. Like, let's say your x-intercept was 2.375. I bet something like Desmos.com would actually tell you legitimately or exactly what it was. Or you could Google something, or there's all kinds of technology out there. But I'm just saying, probably your most consistent pencil and paper way is to plug 0 in for x and solve for. I take that back. Plug in 0 in for y, and just solve for x. Anyway, wow, that was. I rambled so long, I made myself sneeze there. Already did this. Already did this in 2-3. We already had class here in the spring of 2019 here, second semester. And the students I have right now weren't that familiar with this coming from their Algebra 1 class. So you may or may not be familiar or familiar enough right now with this other amazing form. We got standard form, which doesn't really help much, to be honest. Recall that this is standard form, so this equation we were just talking about forever was an example of standard form. Doesn't really mean much. But slope-intercept form like this, amazing. And then there's this point slope form that goes y minus y sub 1 equals m times the quantity of x minus x sub 1, where m again is, of course, the slope, and x1 comma y1. Look, x1 comma y1 as a pair is any point on the line, or it's a point on the line. And so I know it looks weird, but this is an example of an equation that's in point-slope form. And we can just look at the equation and see that the slope, y minus y1 equals m. So our slope is 2/3. And the point, one of the points on our line is x1 comma y1. Now, let's take a breath here for a sec. I want you to notice that there's a negative built in. There's a minus built in here. This says x minus x1, and over here it says y minus y1. There's a minus built in there. So our x1, this says plus 5. You know what that means? That means our x1 is actually negative 5. Because you could think of this as saying minus a negative 5. Look, minus a negative 5. Minus a negative 5 to get the plus 5. And over here, it's minus y1, minus y1. So y1 is just 1. Okay? And last thing I can't help but point out before we move on is that, look at this. Think about what we call these forms. It's not like they made up some crazy new name. Slope, intercept form. Hello. Slope, intercept form. And here, point, slope form. Again, hello. Point, x1, y1. Slope is the m form. Point, slope form. So the last thing in 2-4 is going to be writing equations. You are given certain info, and you're supposed to write an equation of the line that's being, described, or that pertains to what they're telling you. Like if they tell you a slope and a y-intercept, like if they literally give you those two things, like just openly and freely, like that is the problem. They say, what is the equation of the line if the slope is 3 and the y-intercept is 4? Let's even write this down. Didn't do this in class this year, but what if we say, well, I don't know if it'll say m, sorry. It'll go like blah, 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 blah. What's the equation of the line if the slope equals or is 3 and the y-intercept, equals, Jeez, that was crazy. Come on, computer. Oh, God. What's that going to mean? That means you just plug into y equals mx plus b. Like, look at what they're giving you for free. They're giving you m and b. So, of course, you're going to just plug into y equals mx plus b, and it'll be 3x mx plus b. Now, you can use point-slope form to write an equation line if you are given openly and freely this information. Like, again, this is like the perfect ingredients for y equals mx plus b, and these are the perfect ingredients for y minus y1 equals m times x minus x sub 1. So like, what if they told you that the slope was 2 and a point was, negative 3 comma 4, right? You would plug in for y minus y1 equals m, which is 2, times x minus x1, so negative 3. So we can, you know what I mean? And I'm just going to stop there, but obviously x minus minus 3 is simply x plus 3. You know, it goes on to say, you know, yada, yada, yada. But let me point this. Actually, wait, do we address it here? Graph line, graphing. No, it doesn't address what I'm thinking of right now. So I'm going to have to talk about this real quick. Especially my current class of Algebra 2 students, they were actually taught, okay, now listen to this, what was emphasized with them was that if they were given these two things, if they were given a slope, like the slope of the line in question, and a random point, that they could use y equals mx plus b to plug into. Okay? So if you were thinking that as I was talking about this, then I'm not surprised. Because even though a slope and a point are the perfect ingredients for this formula, right? You can actually take these ingredients and plug them into here, y equals mx plus b, I guess I should say, and make it work. And so we're gonna do both of those things when we do the last group of examples here. But first, let's hopefully just remind you that parallel lines, I mean, you may or may not think first that, oh, parallel lines are lines that will never cross. They're always the same distance away from each other as they, go on and on and on. But I hope you learned in Algebra 1 the algebra version, the slope version of parallel lines is that how do the slopes of parallel lines compare? Exactly the same. Which makes sense. Parallel lines have exactly the same slope. But how do lines of perpendicular compare as far as slopes? So how do the slopes of perpendicular lines compare? Do you remember this one? Well, they are opposites, but they're also reciprocals. They are opposite reciprocals of each other. Of each other. So opposite reflipricals, if you will. Opposite reflipricals. Remember that forever. And we got some examples here. Okay. Oh, write in standard form the equation of the line with that slope and contains that point. So they're giving us a slope and a point. But they want it in standard form. Now let me tell you something, brother. Sorry, that was a Hulk Hogan homage there. If they want an equation in a certain form, that only means you need to finish in that form. You don't necessarily have to start in that form. Like here, considering the ingredients they are giving me to work with, slope and a point. In other words, a point and a slope. I am going to plug into this guy. Okay? Y minus y1 equals m times x minus x1. Point slope form, where this is going to be my m, this is going to be my x1, I'll write it down, and this is going to be my y1. And so we have y minus a negative 2 equals 2 is my slope times x minus 4. And so this is y plus 2. And I'm going to distribute, okay? I'm going to distribute the 2 here because I am not going to be finishing in point slope form, obviously. We're going into standard form. So the first move is to basically distribute the m through the bubble. And please recall what standard form is. At least in my mind, I just see it as, again, I said this in the last video probably, standard form is merely when you have your equation, go like this. It goes the x term, then the y term, then the equal sign, then the regular number term, constant, okay? The term that's just a constant. So x and then y and then the equal sign and then the term that's just a regular constant, okay? So as I look at this equation right here, I see that I have to get, like the plus 2 is not in the right place here, so I'm going to get that out of there. So y equals 2x minus 10, and it looks like my x term is not supposed to be on the right side of the equation, it's supposed to be on the left side. So let's relocate the x term, and so over here again it's got to go the x term first, and so it's negative 2x plus the y term equals negative 10. And so that's standard form, but not done yet. Listen to this. To go along with the whole like x term, y term, then the equals, the whole ax plus by equals c thing, I don't know if I included it back here. Where is it? Holy moly. But they're going to be real numbers, okay? Not just real numbers, integers, okay? Like we might want to, I don't know if that's like mathematical law or anything for sure. Sorry, but I mean you can at least call it a guideline, if not like, math religion here, etched in stone. But your A and B and C values aren't supposed to be like fractions or decimals and still have you call your equation in like standard form. So these A, B, and C values are going to need to be integers, but also your A value is normally positive. It's politically incorrect, maybe? I don't know. To have your A value, your leading term, have a negative coefficient. So let's say we sort of fix this by dividing both sides by -1, or multiplying both, multiplying both sides by -1, you're going to get 2x, like positive 2x, minus y equals positive 10. And that's probably the more likely. I don't think there's actually anything like super wrong with this. I mean, -2 and positive 1 and -10 are all integers. It's not like they're fractions or decimals per se, But this is probably more likely to be seen like in the multiple choice options on an SAT exam or a Keystone exam. And so I'm going to go, whoa, what did I just do? I'm going to go with this. Now, the other method, okay, hold on, let's not panic right now. This is another option you have, so what you saw in Algebra 1 might have been both of these methods, or maybe just this method, or maybe just this method. But you can also take these ingredients and use this form to get the job done. And so quick explanation here, to use this form, you can plug obviously your slope is going to go in for m right here. And your point can go in for x and y. What this does, okay, plugging in for y, for m, and for x, that opens up the door, okay, to solve for b, you know. Now you can just figure out what b has to be by getting b by itself, and you see that b is -10. So once you know that b equals -10, now you can write your equation, you know, as far as like, now that you know m and b, you can write y equals 2x minus 10. But in this particular problem, as you remember, they didn't want this as your final answer. They wanted standard form. So we still would have needed to take this, just like I did over here, and put it in standard form. And the reason I put this or right here is because this is good, but this is probably better. So positive 2x minus y equals positive 10. Moving on. Write in slope-intercept form the equation of the line through 1, 5, and 4, -1. Okay, in order to write an equation of a line, like whether you're going to use point-slope form or slope-intercept form, what do you need? No matter which one you do, what's the common denominator there? Pun intended. What's the common denominator? Slope. You need slope no matter what strategy you use. Now, they're not giving you the slope, but aren't they kind of giving you the slope? Or at least aren't they giving you all you need to figure out the slope? Of course they are. If they're giving you two ordered pairs, two sets of coordinates, you of course can use this formula to get m. All right, that was tough. Now we have m. Now we know that m is -2. And now, once we know that what m is, this example is just like this example. They're the same. And if you were going to use y equals mx plus b, which is this option. Again, I'm not going to reteach everything. We just did the same thing on this example. Okay. The only new plot twist was that we had to find m off to the side as our first, step. But what was I saying? Oh yeah, so obviously we'd be plugging in our -2 that we found, right? Our -2 in for m. And then as far as what we would plug in for x and y, you can choose either point. Doesn't matter. You could have picked 4, -1 to plug in. You know what I mean? But we also could have done this, and once again, you could have picked you could pick 1, 5 to plug in for your x1, y1, or you can pick the 4, -1. I mean, to me, I usually point out the fact that, hey, over here, finding m, we literally just got done calling 1 and 5 our x1, y1. So why not just stick with 1 and 5 being our x1 and y1 in this formula as well? But you don't have to. Some people would say that 1, 5 is the better option because there's no negatives. Hey, if you can avoid using negatives, some people like that. So I'm going to leave it at that. You can feel free to try this method on your own, plugging into this, And you obviously can know whether you're correct or not, because you should be getting this same exact answer of y equals negative 2x plus 7 when you're done with this. Because this says we're going to be ending in slope-intercept form. What the heck, I'll do it super quick. If you want to pause the video now, do it. 3, 2, 1. Right, here we go. Y minus 5 equals negative 2 times x minus 1. So y minus 5, I'm distributing the negative 2. Because negative 2 times negative 1 is positive 2. I'm going to add 5 to both sides to get y by itself, because once y is by itself, it'll be done. Okay, 2 more problems, I believe. Write in slope-intercept form the equation of the line that contains... Okay, so they're giving me a point, but what else do we need? We need the slope, of course. We always need the slope. They're not telling us the slope. Or are they? Contains 3, 1 and is parallel to this, to the line represented by this equation. And you know what parallel means. Same slope, okay? Now, listen. We're going to take this and just get its slope. We're not going to plug into this equation. We're not going to work this equation around and move things around, play around with the equation. No. We're going to build, we're going to build our equation from scratch, but we need our equation to be parallel to this equation, meaning we just need to know what the slope is so we can use the same slope. 2. M equals 2. So, look, again, we're going to build our equation from scratch by using the point 3, 1, and we're going to use the slope of 2, all right, to build our new equation. And remember, this method is about plugging in for y, m, and x, just so we can figure out what b has to be. Turns out that b is going to be negative 5, and now that you know b as well as m, we know that our equation is going to be y equals 2x minus 5. Or your other option was to plug in to this formula, point slope formula, where you're going to plug in the 1 for y1, m was 2, of course, and we're going to plug the 3 into there, distribute the 2, add the 1, negative 6 plus 1 is negative 5. And this last, I believe it's the last example. Well, for now anyway, until section 5, 2-5. Yeah, this is the last example. And this problem is going to be very similar to the previous example. They're giving us a point. We need to figure out slope for ourselves. It's just that this one is perpendicular. Remember, perpendicular does not mean same slope. It means the opposite reciprocal. Now, the other way this example is different is that, how do I know what the slope is of this other line, this other equation? Because this is not in the form we like bestest. So basically, okay, a little bit extra work. We need to, of course, solve for y, so we know what slope we want our equation to be perpendicular to. Turns out that this slope is, of course, -3/2. So we want our slope, when we build our equation from scratch, we're not going to tweak this equation around for a final answer. We only want m from here. That's it. And so we learned that it was -3/2, but we want our equation slope to be perpendicular, opposite, reciprocal, so +2/3. All right? +2/3. Pause the video if I'm going too fast and write that down. And now that we know a point and a slope, we can do this whole song and dance again. And we have, as always, at least these two major algebraic options. Our y1 looks like it was 5. Our m was +2/3. And so usually I don't know, normally I can be, well, normally I am way more heads up and just immediately write this as x + 3 instead of -3. Now I'll distribute, of course, on my way to slope-intercept form, because did it say? Yes, it did. Slope-intercept form. So, wait. What? No. What am I doing? Where am I going? -5. So not an equal sign, -5. 2/3 times x is 2/3 x. 2/3 times 3 will be 2. Now I finish getting y alone. And of course, no matter which method you use, you get the same final answer. And yeah, that should do it for 2-4.